Good afternoon to everyone. My name is Veronica Bindi. I'm Associate Professor at the Physics and Astronomy Department of the University of Hawaii. At this time, I'm in Switzerland at CERN, that is the largest laboratory for high energy physics. And the building that you see behind me is the control room, Payload Operation Control Room, POCC. For the Alpha Magnetic Spectrometer, AMS, that is an instrument installed on the International Space Station. Today I will bring you inside the Payload Operation Control Center so that you can see and you can experience what we do every day to monitor our instrument in space. Please follow me. Okay, here we are inside the Payload Operation Control Center, POCC, for the Alpha Magnetic Spectrometer. What you see here are some pictures of the integration phase at CERN. Here you see during the integration in the clean room. That's why all the people are all dressed up in this way. Everything needs to be clean to send an instrument in space. And this is our detector before ready in Kennedy Space Center before being launched with the space shuttle. To get inside, you need a special pass that gives you access. And once you get in, here what you see is an image of the space station where is indicated the location of AMS. You see this little detector here in the external RAS of the space station. Then you can see some videos, pictures of our detector on the space station, a mock-up of AMS and all the different sub-detectors. What you see here are all the different sub-detector, transition radiation detector, upper TOF, tracker, lower TOF, magnet, reach, tracker, and ECAR. Here we have a picture of the crew, of the astronaut crew that brought our instrument on the space station. Here we have a monitor that is going constantly and is an event displays. So what you see here, the red curves coming down, these are particles crossing our detector. So it's a simplified view of our detector. On the other side, we have another mock-up of the AMS instrument, and here on the top you see the people that are doing the shift right now. Here you can see a big window, and we can now go inside the control room. Again, to get into the control room you need a special pass, and this is our control room. You can see all the different locations. Each of them, they have a specific tasks to do. You see the monitor show in real time what's happening on the International Space Station. Up here. And here you see some position like MS command, data. And then we have the lead position, and then we have the subdetector positions. Here on the top we can see where we have the band to transfer data, critical data on ground, while here we see the location of the space station. Right now is close to South Africa, with the future orbit of the space station, and there is also the location of the different satellites. These are also information about the space station. What you see there is an event display, while here we have additional monitoring position. VQ and trigger. Here we have the thermal control system, and here we have the MS data quality we can go and meet someone that is taking the shift right now. Hello, hi.
Hi Veronica. How are you
Can I
doing?
disturb you for a second?
Yeah, sure.
Can you please tell us who you are and what are you doing here?
Okay, I'm Carlos Delegado. I'm from CMAP, it's an institution in Madrid, in Spain. I'm just taking the shift of the PM detectors with photomultipliers. Essentially. Okay, what I'm doing is just to check that the detectors that have photomultipliers in AMS are working properly. So essentially what I do, okay, you know, we have 3 screens. And in one screen, this one there, we check that the ridge detector works. That is a detector that measures the velocity of the particles with a high precision, and we just check that all the system is working as we expect. Here, in this other set of screens, we check that the TOF is working. The TOF is a detector that provides the trigger to AMS and also measures the velocity with less precision than the ridge, but still a very good precision, and just tells us also what is the direction of the particle, if it's coming from up or from down. And then in this last screen here, we check that the ECAL is working. The ECAL is a detector that also provides a sort of trigger for some particles and measures the energy with high precision of the particles that are electromagnetic. Essentially, that's what we're doing.
Okay, thank you very much. Okay, I've seen here there is someone taking a shift for the lead position in the MS control room. Do you want to tell us something about who you are and what you are doing here right now?
So yes, I'm a student, a third-year student in during my undergraduate studies in Switzerland. My name is Ivan Roshkov, and I'm studying physics. I'm here only for the summer. I'm a summer student in AMS, and I'm on the lead position, who is the most important position in the AMS POCC, so the Payload Operation Control Center, and I'm just monitoring the health status of the AMS experiment, and here is the main screens of this experiment. And yes.
So, what are you seeing here? What are you checking?
So here we have the heartbeat of AMS. So this is the main important informations what we get first, and when we have an error on AMS or something like that, we will, it's the main screen where we will see that, and after that we have some additional screens to check what the problem is exactly.
Okay, and I see that you have an headset. Can you explain why you're wearing this?
Because I need to hear what NASA is planning to do and what NASA is doing now, because everything which is done on the space station can have an impact on the AMS health status. So we need to be aware of everything, and NASA also can call us to say what they're planning to do or something like that.
Okay, thank you very much.
You're welcome.
Hello, I see another person in shift that probably can tell us what he's doing and part of his job.
Hello, I'm Robert from China, and now I'm in the thermal shift to check the temperature of the whole AMS, whether it's okay or not. So you can see on these computers, there are the lines indicating each part of the AMS. I see the TRK or the UG. See, the temperature is changing when the ISS is traveling through the orbit. You can see it clearly. It changes every 90 minutes because the whole time the ISS travels through the orbit, it takes 90 minutes.
Okay.
Yes, and these are the temperature changings.
From all different sensors.
Yes.
And what do we have here?
And these are the exact temperatures values in this computer.
So how much does it vary the temperature in MS right now?
Because you can see they are becoming black because we are in the LOS region. We cannot, which means we loss of signal. We cannot
Okay.
receive any signal in this region.
In this moment.
Yes.
And when we get again the signal?
You can see on the big screen, it will be back in 10 minutes.
Okay. So in 10 minutes we will get back
Yes.
the values of the temperature. Here I see that anyway the temperature there, are they all above 0 degrees Celsius? Oh,
Yes, most of them are above,
but this year,
Yes.
yes, they are a bit below
but
and
is keeping changing because the orbit is
around
changing. Yes.
the Earth. Okay, nice. Are you located here at CERN or you just came for the shift?
I'm studying in the University of Geneva, and I came to shift a lot.
Okay,
Yes.
yeah. So in Geneva, that is here in Switzerland, and
Yes.
is the nearest city to CERN, where CERN is located. Yeah, of course you have to come often because you are really nearby. Okay, thank you very much.
Thank you.